Okay, so we are nearing the end of our terms work and we're nearing the end of the calculus. So let's dive straight into this example. So a farmer has 300 apple trees, each of which has 70 apples. Presently, each apple can sell for 50 cents. So it says, what is the crop presently worth? Well, the crop will be worth, there are 300 trees, each of which has got 70 apples, each of which is worth 50 cents. So this is what the crop will be worth in cents. Let's just have a look at what that comes to. So 300 times by 70 times by 50. Right, that's what it's worth in cents. Let's divide that by 100 to get it to rands. So it's currently worth 10,500 rand. Okay, now the good news is that the price of apples is going to go up by 10 cents each week. However, the bad news is that each tree will lose 2 apples each week. So now the question says, what will the crop be worth in T weeks' time? Okay, so let's people often find this difficult. So let's not use T. Let's look at 2 weeks' time. Let's look at what would happen in 2 weeks' time. How many trees will there be? Well, there will still be 300 trees. How many apples will there be? Well, there will be 70, all right, minus 2 lots of 2. Okay, and the reason it's 2 lots of 2 weeks' time, all right? And the reason for this 2 over here is because each week, each tree loses 2 apples. So in fact, on each tree after 2 weeks, there will be 66 apples. Does that make sense? It always makes sense. Okay, all right? The price is going to go up. Now, the price is going to go up by, the price will be 50 plus 10 cents times by 2. And that 2, again, is, so in other words, the price will actually be 70 cents per apple. Okay? All right. That 2 is this 2 over here. Okay. 2 weeks. All right, so now once we've dealt with it numerically like that, it's quite easy to see that after T weeks, all these 2's must just be replaced with T. The crop value, the crop will be worth 300 times by 70 minus 2T. That 2 is that yellow 2 apples per week, all right, times by 50 plus 10t. 50 plus 10t. All right, and that 10, okay, we didn't actually highlight that 10 previously, but that 10 there, that 10 there is the 10 cents. Okay, it's the 10 cents from there. Okay, so that's what the crop will be worth. Okay, now we want to differentiate this because we want to find out where that happens. We want the derivative to be 0. So what we're going to do, still here, we're just going to work out what this actually simplifies to. So if we multiply 70 by 50, we get 3,500 minus 100t plus 700t. So it's actually plus 600t. Minus 20 t squared. And then we've still got to multiply the 300 in. Okay, so it's actually going to be, we're going to do it down here, 300 times 3,500. I am cheating and using my calculator on the side here. All right, that is 105. With 4 zeros, plus 18 with 4 zeros, t, minus 6,000 t squared. Okay, we're going to differentiate this and we're going to equate it to 0. So c dashed is actually, that's going to go away. We're going to get 18, 1, 2, 3, 4, minus 12,000 t equals to 0. Okay, so now the last thing we're going to do is we're going to add 12,000 t to both sides. 18. Okay, and we're going to divide both sides by 12,000. So we've got 18, 0, 0, 0, 0, divided by 12,000. And we get 15. Right, t equals 15. So 15 weeks, that's the amount of time. That's when the harvest should be made. All right, and then obviously the actual what the crop is worth, the maximum profit. All we need to do is we need to put 15 into this formula here. Okay, so let's just do that. So we're going to go 105,000. We look at this line over here. All right, plus 18,000. 18 with 4 zeros, times by 15, minus 6,000 times by 15 squared. And we get, that's in cents, not in rands, so we need to divide that by 100. And we get 24,000 rand. Okay, so the crop is worth 10,500 rand today. But if we wait, it will be worth 24,000 rand. Okay, and again, calculus helps us to calculate that. Right, let's look now at this question here. A boy has a 100 centimeter piece of rope. He cuts it into 2 pieces and forms a square and a circle. Okay, so suppose the sides of the square are x. Okay, all right, there it is. X, 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 X. How much rope does he have left for the circle? Well, he had 100 centimeters and he's used 4x here. So the circumference of this is 100 minus 4x. All right. Now remember, circumference is pi times diameter. So diameter is the circumference over pi. So the diameter of the circle will be 100 minus 4x over pi. And the radius will be half of that. So the radius of this circle, if we just halve the top, we're going to get 50 minus 2x over pi. Right. The question asks for the area of both shapes in terms of x. Okay, the square is easy. The square just has an area of x squared. The circle has an area equal to pi times the radius squared. Now the radius squared is going to be 50 minus 2x over pi, and we're going to square that. Right. Then it says, find the value of x that will minimize the total area enclosed. Okay, so the total area, we'll call it t for total, is going to be x squared plus 50 minus 2x over pi all squared. And we want to minimize that. At that point, the derivative of t will be 0. Okay, so we're going to differentiate this thing. You're going to have to get rid of the brackets first. We get t equals x squared plus 2,500. This product doubled, so minus 200x plus 4x squared, and all of these things are over. it's over pi squared, but we could actually write them like that: pi squared, and pi squared. Pi squared is just a number. Right, now we're going to differentiate. T dashed is going to be 2x. This is just a constant, so it'll go to 0. This is going to be negative 200 over pi squared. And this last one is going to be 8x over pi squared. Okay, and we want this to equal 0. So if we take x out as a common factor of these two terms, this term here, this yellow term, and this yellow term, what we'll get 2 plus 8 over pi squared. And let's add this 200 over pi squared to both sides. And so finally our answer is going to be that x must be 200 over pi squared, all divided by 2 plus 8 over pi squared. Okay, and let's see what we get as our final answer here. Right. (200 over pi squared over 2 plus 8 over pi squared, and we get 7,21 centimeters. Okay, so that's the size that we must make for the square, and that will minimize the overall area. Okay, we're going to ask you to pause and try question 14, and then we'll go over it shortly. Okay, so we're told that B has got coordinates x0. Right, so what will be the coordinates of C? Well, because this is a right angle triangle, this x value will be exactly the same. But we don't want to use y, we don't want another variable. This graph has the equation of negative 0,1 x squared plus 8. So if that's the x value, the y value is negative 0,1 x squared plus 8. Okay, so now it says, what's the maximum area of the, or what's the area of the triangle rather? So the area is just going to be half the base is x, times the height, which is negative 0,1 x squared plus 8. All right, and now we want to maximize that area. So we want to, if we look at this graph, we want to differentiate it. This function rather, let's get rid of the brackets first. A half times 0,1 is 0,05. So it's going to be negative 0,05 x cubed plus 4x. Right, we're going to differentiate that. So a dashed is actually going to be negative 0,15 x squared plus 4. We want that to equal 0. All right, so x squared is actually going to be negative 4 divided by negative 0,15. All right, and we can work out our x value quite easily from here, because I don't know what I did with my calculator there. There it is. So let's just work out what 4 over 0,15 is. It's 80 over 3, and then we're going to square root that answer. So we get about 5,16. X is 5,16. That's not the maximum area, that's what x must be. All right, the maximum area, we're going to put that x value into our area formula. Let's do that right now. So we're going to just work with our that is currently in the answer. We can just check that. Answer equals, there it is. All right, so we're going to go 0,5 times the answer, open brackets, negative 0,1 times our answer squared plus 8, close brackets, equals, and we get 13,77. 13,77 units squared. That's the maximum area. Okay, there's one more question, and that's this one over here. I think it's the last one before we get into the practice test. Yep, it's the last one before we get into the practice test. So, the courier company will accept a parcel as long as the 3 dimensions added together do not exceed 1200 centimeters. So obviously to make it as big as possible, we want the dimensions to add up to 1200. Okay. The base is going to be twice as long as it is wide. That's x. Okay. This will be 2x. And the height, we want the height plus 2x plus x to be 1200. We want to make it as big as possible, so let's go with 1200. So we know, in fact, that the height is going to be 1200 minus 3x. Okay, now we've got all of our variables, so all of our dimensions in terms of one variable. So let's work out the volume of this box. It's going to be 2x times by x times by 1200 minus 3x. Right, that's the volume, and we want to make that as big as possible, so we want to be over here where the volume derivative is 0. We're going to have to multiply it out first. We get 2x squared into 1200 minus 3x. We get 2400 x squared, sorry, 2400 x squared minus 6x cubed. Right, now we're going to differentiate it. V dashed will equal 4800x minus 18x squared. We want that to equal 0. We can take out a common factor of x. So we're going to get 4800 minus 18x equals 0. Now, x could be 0, but if x is 0, we're going to get a box of 0. That's the minimum box, all right? Or x is 4800 over 18. And that will give us the maximum volume. Okay, let's just see what the question asked for. It just asked for the value of x that will result in the maximum volume, and then it says also give the maximum volume. So that's the value of x. The volume max will just be found by putting that value into our equation for our volume. Okay, and we've got our equation for our volume. Let's have a look right there. 2400x squared minus 6x cubed. So our x value is 4800 over 18. 4800 over 18. All right, there it is. And we want to now use that value into this formula here. So 2400 times answer squared minus 6 times our answer cubed. And we get, we have a vast number here. That is in, okay, I'm actually just going to show you again. This is, that will be in centimeters cubed or something. I'm just looking, this was 1200 centimeters. Okay, so our value for x is 4800 over 18. our value for x is actually that many centimeters. If we divide that by 200, sorry, by 100, we'll get it in meters. Okay, so it's 2,7 meters. X is about 2,7 meters. So now we're going to put that value into here, and then we'll get our volume in meters cubed. All right, so we've got that answer in there. There it is. So now we go 2,400 times answer squared. 2,400 times answer squared minus 6 times answer cubed equals, and we get 160. That's still not looking quite right to me. I think something's gone wrong here. Okay, yeah, the number just looks way too big. 2,6. Yeah. Okay. I'm fairly confident about the 2,67. We're just messing up the actual value here. Let me just pause and have a look. So I think it comes to 132 meters cubed. Okay, so it's a very, very big box. Okay, I've realized that this 1,200 centimeters is actually 12 meters. So we're talking about a massive box, which is what was throwing me earlier. Okay, right, we're going to stop there. And we will in the next lesson, we will go through and mark this practice test. So if we just have a look, it's just a few pages, and we'll talk about it next time, and we'll go over it. So before then, see if you can try this test. It's a real summary of all of the calculus. Have a great day, everyone.